All right, looking at number 4 in 9.2, we get our first application problem, but as you read this problem and then you practice this type of problem, what you'll notice is that they give you an application problem here, but they're nice enough to actually set up the application problem for you right here. So later in 9.4, you're going to have to be able to set this equation up, so you might get familiar with the language here. And it says that we're putting two solutions together to make 8 gallons, and we want to make an 8-gallon salt solution that's of 35%, and you can see that's down here, 8 gallons at 35%. Okay, and we're mixing two solutions, right? Two solutions to get 8 gallons, and so this is gallons plus gallons equals 8. And then we have one solution is 65%, and another solution is 25%. Okay, so kind of get used to this setup here. And then it says solve by the substitution method. Now, later in this chapter, and even now, you really don't have to do the substitution method. No one's checking you for that, but you should know you're responsible for learning all 4 methods of solving here. So we'll use the substitution method on this, and then I'm going to show you how to use matrices also in this video for the first time. So if I look at this first equation here, I can see that I can manipulate that pretty easily by moving my x to the other side. I can write it as y equals negative x plus 8. Okay, so I've isolated and I'll call this new L1. Okay, so now what I'm going to do is I'm going to take this value and I'm going to substitute it into my other equation. Okay, so as I substitute that into the other equation, okay, I get 0.65x plus 0.25, and then I'm going to substitute my value in here of negative x plus 8, substituting that in for y, equals, and I'm going to multiply this out here on my calculator to get 2.8. All right, so next I'll take care of the distributive property here and multiply this 0.25 into my parenthesis here, and I get 0.65x plus minus 0.25 x, and then plus 2 equals 2.8. And then I'm going to combine my x values here to get 0.4x, and I'm going to move this over and subtract 2, so I get 0.8. And what I find out by dividing by 0.4 is that x is equal to 2. Okay, so that would be 2 gallons of the 65%. So I know if I have 2 gallons here and I need 8 total gallons, then I'd have y is equal to 6. Okay, 6 gallons. And you know, if they have some boxes for you that you have to say, you know, how much of 65% solution, you'd say 2 gallons. And how much of the 25% solution, 6 gallons. Okay, so just make sure you type in your answers correctly. All right. Now I do want to show you how to do this on matrices also. So I'll get the calculator later set up and we'll take a look at that. Okay, I've set up the calculator and we're working on number 4 from 9.2. We already solved it using the substitution method and came out with a solution of 2,6, and I wanted to show you how to use matrices on a graphing calculator, and I'll make another video about this also, but I want to show you the correlation between the substitution method and the matrices method. So if we look at these two linear equations here from the application problem, what I can do is I can kind of shorthand this information and I can put it in something called a matrix. Okay, And what I'm going to do here is I have my x's, my y's, and then my constants, which I'm going to put in this little table here. And notice these, the x and the y are on the same side here, and the x and the y are on the same side here. And then we have our constant value on the right side. So I'm going to take off the coefficients 1, 1, and then the constant value of 8. And then I have 0.65 here and 0.25 for the y value. And then I'm just going to type or write this down for right now, and that's perfectly okay. I could multiply it out, and I think I came out with a 2.8 when I multiplied that out. But this here is our matrix from the information up above, and we want to make sure that when we do this matrix that we line up our x's, our y's, our constants, and we have to have these in the x plus y equals the constant form, okay, to do that. So everything's lined up correctly, and on the back of your note packet for this module, you'll find the instructions of how to do matrices, but I'm going to go through this quickly with you today and show you. I'm going to turn the calculator on. I'm going to hit clear just because there's some junk on my screen, okay? And then I'm looking for this button here that says matrix, and you notice it's above the this x to the negative first power. And to activate that matrix button, what I have to do is I have to push second and then matrix, okay? And you'll see you get 3 options in here: names, math, and edit. What I'm going to do is use my right arrow and go over to edit. And since this first matrix here is highlighted, I'm going to just hit enter, and it's going to give me a spot to enter in the matrix. Now this matrix here is 2 rows by 3 columns. So it's a 2 by 3 matrix. All right, so I'm going to type a 2 here, and I'm going to use my arrow key, and I'm going to type a 3. And to let the calculator know I'm ready to proceed, I have to hit enter. And you'll see I have 6 fields that I can type in my values now. And so I'm going to type these values just using the numbers and the enter key, okay? So I'm going to hit 1, enter, 1, enter, 8, enter, 0.65. I say it in my out loud almost every time. 0.65, enter, 0.25, enter. And I wanted to show you this. You can actually type this in as a multiplication, 0.35 times 8. And what you'll notice, it does the computation for us. We get 2.8, which we had when we did it longhand in the substitution method. Okay. So now at this point, all the data is entered. What I have to do is I have to exit this screen. And so to exit, we have to hit this quit button. Okay. It's a step that many students forget. So I'm going to hit second to activate quit, and I'm back to my home screen. Okay. Now from my home screen, I'm going to go back into the matrix 2 more times. Okay. I'm going to hit matrix. I remember I have to hit the second, and I'm going to go over to math, and then I'm going to push the up arrow because it's a little quicker till I find rref. And rref stands for reduced row echelon form. Okay, so we're looking for rref. All right. Once I find rref, I'm going to hit enter. And right now the calculator is going to be confused because it doesn't know what to perform this operation on, okay? And what I need to do is I need to go back into matrix. So I'm going to hit second and matrix. And I know I put my data in matrix A, so I'm going to hit enter. Now the calculator understands this language of, hey, do reduced row echelon form on matrix A. You don't have to end the parenthesis, but I am going to end the parenthesis here and hit enter. So what I get here is I get a matrix that's in what's called reduced row echelon form. And on the back of your packet, it explains how to read these. But if you look, I first look for this diagonal 1, 1. If I see this diagonal 1, 1, I kind of think, all right, good news. Since I have good news, this is going to be my solution. This is my x value. This is my y value. And we already saw that we had these two solutions. It was 2 gallons at 65% and 6 gallons at, I believe, 25%. So you can see how to use the matrices to get the same answer. So a lot of you are going to adapt to the matrices method. It's a very nice method, and we'll look at some other problems, and I'll make another video about how to do the reduced row echelon form. Okay. Thanks.